What's up, people? Today we're going to take a look at the difference formulas for sine and cosine. If you've seen our other video that shows you how to come up with the sum formulas for sine and cosine, you'll know how we came up with this formula right here. If not, you can still watch it, just check out the link above. Otherwise, to come up with the difference formula for sine and the difference formula for cosine, it's really just a little bit of algebraic manipulation of the sum formulas, as well as having an understanding that sine is an odd function and cosine is an even function. So we're going to first take a look at the difference formula for sine. How do we come up with the difference formula for sine? Well, here's the sum formula for sine that we mentioned earlier. And now what we're going to do, in order to come up with the difference formula for sine, we have to understand that cosine is an even function. What exactly does that mean, that cosine is an even function? Well, we have an x and y axis here. And if I were to put a 45-degree angle here, which we will call B, if it's 45 degrees, then and we make a right triangle here, right, 45-degree angle, we could say the relationship here is going to be 1, 1, square root of 2, right? If we go back to our Pythagorean theorem, 1 here and 1 here, this is going to be square root of 2. And that's for angle B in quadrant 1, okay? This is a positive 1, this is a positive 1, and this is a positive square root of 2, right? Now, if we do the same thing in quadrant 4 here, we got quadrant 4, 45-degree angle, which we will call negative B now. We will just move this little +1 over here so it's out of the way. So now we have an angle over here, same size angle, but it's in quadrant 4. So this is x. We draw our right triangle here. Have this line come down. Draw a little more here. And now we've got a 45-degree angle here as well. So this is positive 1, this x value. This y value now is a negative 1. And this r value, this hypotenuse, is going to be still a positive square root of 2. Now, if we want to find out what is the cosine of angle B here in quadrant 1, what do? Well, cosine is going to be the adjacent side over the hypotenuse. So the cosine here is going to be cosine of B equals 1, the adjacent side, over square root of 2. 1 over square root of 2, which of course you can rationalize. I know many teachers say rationalize the denominator. So you're going to rationalize that, multiply by square root of 2 over 2. And now you have 1 times square root of 2, which is square root of 2, over square root of 2 times square root of 2, which is 2. So now you have the cosine of B equals square root of 2 over 2. Now, if we want to find the cosine of negative B, how do we figure that out? The same way, right? We take the cosine of negative B, and we say that's going to be equal to 1, here the adjacent side, over the hypotenuse, which is square root of 2. So we have 1 over square root of 2, which equals, the same thing, right? Square root of 2 over 2. Therefore, we can see that the cosine of B and the cosine of negative B both equal the same value, square root of 2 over 2. This works for any angle. It doesn't only just work for a 45-degree angle. It'll work for a 60-degree angle, 30-degree angle, whatever you put. So what does it mean that cosine is an even function? It means that the cosine of an angle, right here, cosine of B, for example, is going to be equal to the cosine of its negative angle. They are equal. So we've got our cosine of B equals cosine of negative B. That's going to be a key formula that we're going to use to come up with the difference of sines. We're also going to have to learn that the sine function is an odd function. Now, what does it mean that the sine function is odd? Well, let's find out the sine of this angle again. We've got, again, B is a 45-degree angle. So this is 1, 1, square root of 2. This is going to be negative 1, 1, and this is square root of 2. So we say the sine of B in quadrant 1, the sine of B equals the opposite over the hypotenuse. So we have 1 over square root of 2. And of course, again, your teacher is likely to say, rationalize that denominator. So you rationalize it, And you say times square root of 2 over square root of 2. And of course, we get the same thing. In this case, a 45-degree angle is going to be the same. The sine is the same as cosine. Square root of 2 over 2. Then we're going to do the same thing for quadrant 4. Quadrant 4, sine of negative b equals negative 1. The opposite now is negative 1 over the square root of 2. And again, you rationalize the denominator. So you say that's going to be negative square root of 2 over 2. The only difference is now you got this negative. You're in quadrant 4. So now you notice that the sine of b is equal to square root of 2 over 2. The sine of negative b equals negative square root of 2 over 2. So I've taken the information that we found earlier, and I've got it listed right here. Sine of negative b equals a negative square root of 2 over 2, and the sine of b equals the square root of 2 over 2. And on this side, I took this equation here, multiplied each side by negative 1. And then, of course, when you get negative 1 times sine of b, you get the negative sine of b. And then you have square root of 2 over 2 times negative 1 on this side, and you get negative square root of 2 over 2. So we end up with negative sine of b equals negative square root of 2 over 2. Notice on this side, the sine of negative b equals negative square root of 2 over 2, which is the same amount. So negative square root of 2 over 2 here, negative square root of 2 over 2 here. That would mean, since they're both equal to the same amounts, that the negative sine of b equals, the sine of negative b on this side equals the negative sine of b. And this is the odd function that we're talking about. This is what we need to know in order to figure out the difference formula for sine and cosine. Okay, so we are just about ready to rock and roll here now. We've got our sum formula for sines up here. We've got our even function of cosine. Cosine of b equals a cosine of negative b. Then we've got our odd function for sine. Sine of negative b equals the negative sine of b. And now we're ready to rock. So we want to find this out, sine of a minus b. But we have sine of a plus b. Can we change this a minus b, a subtraction, into an addition? Yeah, we can change this into the sine of a plus negative b, right? Sine of a plus negative b, that's going to be the same as a minus b. Plus times negative is negative, so we have a minus b here, and we'd have a minus b, of course, up there. So we're going to use this sine formula, this sum formula, and basically drop it in here, because we've changed this to addition, and this is an addition formula. So we're going to say this equals the sine of a times the cosine of b, but now our b is a negative b. So we write down the cosine of negative b plus the cosine of a, and here's a right here, cosine of a, times the sine of b. Oh, but our b is now a negative b. So we say sine of negative b. Okay, and now what do we do next? We say, okay, we've got cosine of negative b and we've got sine of negative b. We're going to have to deal with that. So we're going to bring this down here, sine of a, nothing to change there. And then we've got the cosine of negative b. Oh, we've got our even function for cosine, which tells us that the cosine of negative b equals the cosine of b. So this becomes cosine of b. Plus, then we have this sine of negative b. Oh, but wait a minute. Sine of negative b right there tells us that that is equal to the negative sine of b. So we write down negative sine of b times the cosine of a, because that doesn't change. Now, what happens when we multiply the negative sine of b times the cosine of a? We get minus, and I'm just going to bring the cosine of a in front. Remember, multiplication is commutative. I can write this as minus sine of b times cosine of a, or I can write it as minus cosine of a times the sine of b, and everything else stays the same here, equals sine of a cosine of b. So there we have it. There is our sine of a minus b formula. This is going to be sine of a cosine of b minus the cosine of a sine of b. And that is our difference formula for the sine of a minus b. Okay, so we are all set here to come up with a difference formula for cosine. We've got our sum formula for cosines up here. This is a formula we derived in our other video. Click on the link on this page and you can see how we derived the sum formula. Now all we're going to do to find this out here, the cosine of a minus b, is we're going to use these three formulas to help us figure that out. First thing we have to do is we say we have a minus b here. But we don't know what that is, but we have a plus b. As we did with the sine formula, we say, okay, can we rewrite a minus b, which is subtraction, can we rewrite that as addition? Of course, this is going to be the cosine of a plus negative b. And why are we doing that? Again, a plus negative b is equivalent to a minus b. And now that we have this written as a addition situation, we can use this formula right up here. We can just substitute this in and say, okay, this is going to be the same as the cosine of a times the cosine of b. Oh, but we're not using b in this formula. We're using negative b. So this is the cosine of negative b minus the sine of a, still using a there, sine of a, times the sine of b, oh, but we're going to use a negative b here. So we have negative b, sine of negative b. And now we're just going to simplify this a bit. We've got the cosine of negative b, and we've got the sine of negative b we have to deal with. So we say this is going to be the cosine of a times the cosine of negative b. Oh, negative b, what's that going to be? The cosine of negative b is going to be the cosine of b. That's what our formula tells us. So we're going to change this to cosine of b minus the sine of a times the sine of negative b. Oh, sine of negative b equals the negative sine of b. So this is going to be minus the sine of a, comes down, times the negative sine of b. And now we just got to simplify this. What's the sine? The negative sine of a times the negative sine of b is going to be plus sine of a sine of b. And this stays the same, comes right down. Cosine of a cosine of b. And there you have it. There's our cosine of a minus b. I'll write it up here. It's going to be cosine of a cosine of b plus the sine of a times the sine of b Thanks for watching. Hope you enjoy what you saw. Please feel free to rate this video, leave any feedback or comments in the comment section, subscribe to our channel, and check out some of our other videos. We'll see you next time.